Hello and welcome to another lecture on control system. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Engineering College, Electrical Engineering Department. So today we will discuss about the force voltage analogy and force current analogy, or electrical equivalent circuit to a mechanical circuit. How we can find the equivalence between a mechanical circuit and an electrical circuit by using the force voltage and the force current analogy. So till now we have already learned about the mathematical modeling of a physical system to the mechanical system, the nodal analysis of the particular mechanical system in order to draw the transfer function in both cases. So today we will discuss about the force voltage analogy. Now let us first we will discuss about the force voltage analogy, means how force and voltage or mechanical circuit can be replaced by an electrical circuit or electrical equivalent circuit. Force voltage analogy that we are studying on the force current analogy, that two part that we will go to study today. So let us take a mechanical system. In order to make it analogous with an electrical one, so that we can easily use the aim, this is the B, the dashpot or the damper that we have seen. We have already known to us to provide the frictional force, and aim is generally present to give the inertial forces in spring, which is then used to provide the restraining forces. And just round it, and there is a displacement is occurs. X, and the force, that is F, is applied to the system F. So the general equation, and let us take a voltage source. The electrical circuit, the RLC circuit, equivalent to the, how we can make it equivalent. That is an RLC circuit. The voltage that is applying is V, that is R, that is L, and that is the C, and the current that is flowing through the circuit is known as IT. So what is the equation for that particular system? The physical system can be written, equation can be written as M F equal to, that we have done, M into D, D, D2x by dt square, that is known to us, plus B into dx dt plus K into x. So now for the particular mechanical system. Now for the electrical system, the voltage can be written as V equal to I into R. L di dt, the voltage across the inductor, is known to us, and voltage across the capacitor can be written as Q by 1 by C integration of I dt. So we know that I equal to the current is rate of change in charge. That is ddt of Q. So just putting this value, the replacing the value of the I by d Q dt, we have get that the equation can be written as L into d2 Q dt square plus R into dq dt plus Q by C. So now I am comparing those two equations, this one with that one. So the force voltage analogy, there is a vice versa case, means we are converting force to voltage or say voltage to force. It is given that in case of this force voltage analogy, the mass is equivalent to the inductor. Means mass can be replaced by inductor or inductor can be replaced by mass. This one is equivalent to this one. This one is equivalent to this one. And B can be equivalent to R. B is equivalent to the vice versa case also R. And now that K can be equivalent to 1 by C. 1 by C. This question is 1 by C. So K can be equivalent to the capacitor of the circuit. Means if there is any K, that can be replaced by the capacitor. And it is easily seen that charge can be replaced by Q. A charge Q can be replaced by X. Same. So charge Q can be replaced, X can be replaced by here in the sense of Q. This is the force voltage analogy. Means how we can easily find the replacement of force voltage and the current. This is called the force voltage analogy. So let us take another portion. Find the same thing with the help of force current analogy. Same thing can be done with the help of force current analogy part. So we can easily relate that how they are related to each other. So we have done the force voltage analogy. Means if there is a voltage source, how they can be replaced, the resistance, the inductor, the capacitor, and also the charge can be replaced. That is easily found with the help of force voltage analogy. Now I am going for the force current analogy in order to find the going for the force current analogy. How force and current is related to the force current analogy. So let us take an current circuit in order to find the comparison between force and the current. Say RLC circuit, RL and the C circuit in order to find the force current analogy. This C, that is L, and that is R. So the current is given as I. So current through the resistance is IR, and for inductor it is IL, and for capacitor it will be IC. So now I am comparing the conception of force current analogy. Now force is related with the current. So if I draw the equation, total I will be summarized, it will be divided into three parts, that is IR plus IL plus IC. So IR can be written as V by R. Say there is voltage source in terms of V, plus IL can be written as 1 by L integration of V dt. IC can be written as C into dV dt. C into dV dt. So we all know V equal to d phi by dt. That is known to us. Rate of change in flux with respect to time. So just putting those values, I am getting I equal to C into phi d2 phi dt square plus 1 by R into d phi dt plus U by R U by L. So if I make the equivalent of the two equations, this one and this one, so the force current analogy will give that force current analogy will give that force current analogy. This is the force voltage analogy, and this is the force current analogy will give that force is equivalent to current and vice versa. Followed by M is equivalent to the capacitor. D is equivalent to the 1 by R of the resistance. B, that is equivalent to 1 by R, the resistance. P is equivalent to 1 by L. equivalent to vice versa. And the last and the final is that x is equivalent to 5. So that is where we can easily nullify the conception of this is called the force voltage and the force current analogy. We can easily replace the mechanical system with the help of force voltage and force current. So let us take an example in order to find the force voltage and force current analogy. So let us take an example. How we can easily approach to the force voltage and force current. Displacement is x1, displacement is x2. V1, this is K1, this is M1, this is M2, B2, this is K2. So first we are going to the force voltage analogy. First we are going to the force voltage analogy, then we go for the force current analogy. So in order to find the force voltage analogy, first of all, number of masses. You have to remember that number of masses, number of masses equal to number of loops, equal to number of loops. Number of masses equal to number of loops. So here are how many masses are there? Two masses. So we can easily just draw with a light, just to make it remember that we are drawing with a light pen. We are drawing with a light pen. That there are two mass systems. We have two loops in the system. For the force voltage analogy, we are drawing a two loop. Okay, we are drawing a two loop. Now we are considering on the force voltage analogy. So it is seen that in case of the force voltage analogy, first the force, this force F is replaced by the voltage. So I am putting a voltage source here, V. Okay. Then for that particular mass, this is for the M1 mass and this is for the M2 mass. That is the B1 and K1 is collected with the M1. So B1 means B must be replaced by the resistance R that we have seen. So we have drawn a resistance R. We have drawn a resistance R. So we are drawing a resistance. So it is seen that the mass, that is the mass, can be replaced by the. So what is the force? First we have to know the. I mean, there is a force must be replaced by the voltage, or the force voltage analogy. Mass must be replaced by the inductor of the circuit, that is L. B must be replaced by the resistance of the circuit, R. And K must be replaced by the inductance of the circuit. It is 1 by C. So here mass M1 must be replaced by the inductor L1. So draw inductor L1 that is connected with the first we have considered that what is connected with the L1. So inductor is connected with the L1. So draw the L1 first. That is M1 is replaced by L1. Clear? So what is between M1 and M2? This is the common part between M1 and M2. This is for the M1, this loop is for the M1, this loop is for the M2. So what is common between M1 and M2? One is B1 and one is K1. So it is clear that what is common between M1 and M2? It is the B1 and this is the K1. So B1 must be replaced by the R1. B is replaced by the R. So that is the B1 is replaced by the resistance. That is the resistance R1. And another is the K1. K1 must be replaced by the capacitor. So another is the capacitor. That is the C1 capacitor is there. So the loop 1 is completed. Now for the loop 2 M2, it is connected to the K2. So K must be replaced by the capacitor. And another is the M. M is the inductor. M must be M2 must be this is loop for the M2. So M2 must M must be replaced by the L2. So first write the L2. Anywhere first write the L2. So M is replaced by the L2. Followed by the B must be replaced by the resistance R2. L2. So B must be replaced by the resistance R2. Rather this is the resistance R2 and K must be replaced by the capacitor C. This is the C2. K is replaced by the capacitor C2. So this is the way that we can deal with the force voltage analogy. Use the equivalent electrical circuit with respect to a mechanical circuit with the help of force voltage analogy. Now we are approaching to the force current analogy. In order to replace the force current, it is very easy from the force voltage. That is, it is given that in case of the force voltage to force current, that it must be known as the voltage will be replaced by the current, L will be replaced by the C will be replaced by the L, and R will be replaced by R. Series branch will become the shunt branch, and the shunt branch will become the series one. Series will be shunt will be series, C will be L will be C, R will be remain R, and voltage must be replaced by the current. So first I draw the voltage that is replaced by the current. First, this is the voltage, so V is replaced by the current I. Then followed by that, this is connected in series branch L1, so it will be go to the parallel branch, and this series one must be replaced by N. First series will be connected in the parallel, and L will be replaced by a capacitor C. Where the series branch is go to the parallel branch, and L is replaced by the capacitor C, is called the capacitor C, is called the C1. And again this series branch that will be replaced by a parallel branch. So R will be remain R. There is no change in the R, but that C that is connected in series with the R will be go as a parallel, and it will be the L. This capacitor will be changed to the inductor. So it is now L1. Third one is L. R and C is connected in the series and they will be now connected in the parallel. The series branch will be go to the parallel branch. So R remain R, and this is R2, but the L2 became the C2 capacitor. L2 became the C2, the capacitor. R2, L2 became the C2, and C2 became the L. C2 became the inductor. L. So this is the way we can able to easily design the we can make voltage source equivalent current source and we can make an electrical equivalence to a mechanical system. So means the R becomes R, L becomes C, C becomes L, series branch becomes shunt branch becomes series branch. So that is where we can find the force voltage and force current analogy of a mechanical system. So today we have learned about the force voltage and the force current analogy. So means equivalent electrical equivalent to the mechanical system and how we can transfer a mechanical system or a physical system to an electrical equivalent voltage source system or a current source system with the help of force voltage and the force current analogy that we have done today. Thank you.